metals. So it's a process of getting the metal from the ore. Maybe those of us who teach chemistry might find this one a bit friendly, but will not make it to look more of the science. I think I'd opened something here. Let me see. Extraction of metals. Just a moment, sorry. Yeah. What is happening? Sorry, I'm trying to share a window which seems not to be coming. That one. Good. Let me reopen it.
Let us up, Kisirani ilimkako. Kumbe haingewezekana tu vile ulisema.
Sorry, I don't know why the window is not coming.
Why do we waste time? Why do we waste time with someone whom we don't know even if they will attend?
Maybe I think so. I think the proposal of the class is maybe we start. Let's just start. Let me just try to share. There's something which is not coming. I don't know. Uh, okay. Okay, okay. Oh, they seem to be. Mhm. Okay. Let me start to share. I don't know why it's not. Today it's misbehaving. It's not bringing the. Which window? I don't know what is happening today. Share. Oh, it's refusing to share. I don't know what's happening. Top tab. Windows. Just allow me to leave and then I join again shortly, kindly. Just shortly. Okay, let's try to see if it will share. Yeah, I think it has accepted. Sorry about that. Okay, I don't know if you can see something on the screen. Sorry, we'll try to move fast.
Yes.
Okay, so yeah, that's what I wanted. I think I'd joined using a wrong browser. Okay, so I think let's just move a bit fast. Sorry, I've wasted time, but it's okay. So we are going to talk about extraction of metals, and this is what we refer to as metallurgy. So metallurgy just is the study of the metals, their properties, and how they are extracted from their ores. And we know they occur in nature, but when they occur in nature, they normally don't occur in pure form. So the most of them will be gotten when they are combined, when they have combined with other elements. Like if it is copper, we can talk of copper carbonate. So you need to convert the carbonate maybe into copper oxide, and then you reduce to get copper, and so on and so forth. So we have extraction of metal. So it's the process of getting these metals from their ores. So there are some terms that we need to know from this. One of them is called calcination. I'll not read the notes word for word, but when you talk about calcination, it's just the process of obtaining these metals by heating them in absence of air. So you just take the ore, heat it in absence of air, and this is done so that it can decompose. So this is done so that the metal can decompose, and then other impurities which are in volatile form can also disappear. So this one, when we do it, we normally heat these metals below their melting point so that they don't decompose. So calcination is not the same as roasting. So if you talk about roasting, in the case of roasting, we heat these materials to drive away part of it. So I think we have a roasting and calcination. Calcination heating in absence of air just to remove the volatiles from the material. But when you talk about roasting, it has to occur with decomposition of the materials so that they form another compound. So roasting is normally carried out in an oxidizing environment, maybe in the presence of air. That's what they mean. So normally during roasting, part of the material disappears. Like for example, if it's copper, copper is normally gotten from copper carbonate. Copper carbonate, we refer to it as malachite, is the common source of copper. So we know that when you heat copper carbonate, it will break down to form copper oxide and carbon dioxide between 250 to 350 degrees. And of course, we know carbon dioxide being a gas, it will escape into the atmosphere, and then the copper can now be reduced later. Another example is galena. Galena is just a lead sulfide. Now, when you heat lead sulfide, it can be oxidized to either lead oxide or lead sulfide. And then this lead sulfide will reduce into lead oxide plus sulfur dioxide. So we will see why we are studying these processes is because they also contribute to pollution of the environment. Pollution of the environment, they contribute to the pollution of the environment. So we have, so those are examples. So roasting, it means we heat in presence of an oxidizing agent, and in the process, part of the material decomposes to give us something else. Now, when you are carrying out this calcination, we normally carry it in what we call a furnace, which is a special chamber that can withstand very high temperatures. So there are a furnace that can withstand high temperatures, and an example of a furnace is shown here. So this is a furnace made up of special material They are called refractory materials, which can withstand very high temperatures. Sorry, there's some things keep on popping on the screen. It is not part of the class. So I think, so this is what we have. So this is an example of a furnace. So this furnace has the top part, which is open, where we introduce in the material to be roasted. And then on the side, we introduce a fuel. So fuel is introduced for heating for producing the heat. And then so we have fuel, and then we also introduce air down here. So you can see we have a fan here. So on the side, we have we introduce fuel to bring about the heating, and then down here we introduce the air, which causes oxidation. And I think as we do that, the material will decompose. So this is an example of the limestone is calcium oxide, no, calcium carbonate, sorry. So this calcium carbonate, you introduce it from up here, and then down here you introduce air, and then on the side now you introduce fuel, which burns the material. So when you burn calcium carbonate, what you get is calcium oxide, which will come out down here as calcium, as lime. So here they say lime out. So lime is just calcium oxide, which we got by decomposing that. So I think in doing this reaction, we normally use a chamber. It's called a fluidized bed reactor. So this is a device that is used for multipurpose reaction. And the purpose is just to ensure that this material that are being reacted, they mix properly. I'm not reading the notes word by word, but the main purpose is just to help in the mixing of the material. So I'll show, so this is what we are talking about here. So we introduce the solid, and then down here we introduce the gas. So the purpose of this gas is it brings in bubbles, and the bubbles allows the solid to separate. And in the process of separating them, you can now end up getting materials that you like. If it's maybe material of different densities, it means when you bubble them up, then you can get maybe the lighter ones coming up, the heavier ones down, and then you can be able to separate. So the most important part here is just to help with the separation. And it's normally used in factories, especially when we're carrying out reactions involving solids or liquids. So the process is known as fluidization. It means you try to make these materials to behave as if they are fluids. They can flow. So you make them to appear as if they are flowing. So introduce a gas which helps in mixing, and then you can now separate them. Now when you're doing extraction, the first thing that we normally do is that, because it's a very expensive process, the first thing is to make sure that we remove the impurities from the starting material. To reduce impurities from the starting material. So you want to make sure that the ore that you are taking into the process of extraction contains as much of the wanted material as possible. So you don't want to take to process something which is very impure, because the process will be expensive and you'll end up getting a impure product. So the method of removing, the process of removing impurities from a metal ore before you do extraction is what we call, we refer to this as a concentration of the ore. We are talking about, you are concentrating the ore. To concentrate the ore means you try to make sure that it has less impurity as possible. So when we are doing this, there are processes that we follow. So there's one which is referred to as hydraulic washing or gravity separation. So this one just the ore is poured onto a vibrating sloped table with grooves, and then a water jet is allowed to flow over. So what happens is the denser material will settle on the grooves, while the lighter ones will be washed away. I don't know if I think I had a diagram to show this. Okay. Maybe I think it's not in here, but here you just you use water and you take advantage of the gravity to wash the ore. So as you wash this, we are saying the lighter ones will move faster and the heavier ones will settle. The heavier ones will settle on the surface. And then we have another process which is called the froth flotation. So during this process, water and oil are mixed together. We know that water and oil don't mix. So you take water, oil, and then you mix together with the ores. So what will happen is that air will be bubbled through the solution, and because of the different wetting properties, the ore may contain some impurities which are not easily wetted. So because of the difference in wetting properties of the ore or the particles making up the ore, then it can be separated based on that. So we have a mixture of water, oil, and sometimes detergents and powder are mixed in a tank. And then after that, a blast of air is blown through the pipe over rotating agitator. Agitator is something like a shaker to produce a froth. And then when this happens, I think because of the wetting properties, then the material, the ore gets separated. So some will be attracted to the water, others will not be attracted to the water. So the froth will then be transferred to another container, washed and dried. So in most cases, when you do this kind of separation, the ore will be, when you do this kind of separation, the ore will normally be contained in the froth. So it will be contained in the froth, and you can get now the froth and dry it further. And then we have another one, which is a general magnetic separation. You can use magnets to separate. Materials which are magnetic will be attracted by the magnet. The ones which are not magnetic will not be attracted. So this one is used to separate materials based on their difference in magnetic properties. Then we can use hand picking. So hand picking is for larger particles, and it's based actually on the size. Just a moment. Can I change? Okay. Sorry about that. My battery ran out of power. Many things have happened, but we can just continue. So I think you're talking about hand picking. You can separate just by picking, and this separation will depend on the size and the particles of the material. And then apart from trying to concentrate, you can also do what we call a smelting. I think it's just almost similar to calcination. So when you are doing a smelting, it's just one of the ways of trying to produce the metal from its ore. And it normally involves the metals which are fairly less reactive, like silver, iron, copper, and others. So in smelting, we just heat the material in presence of a reducing agent. And see that when you heat in presence of a reducing agent, the reducing agent can drive off other elements from the ore or from the slag, which is just the heated product to form the metal. Like we know when you heat copper, when you heat maybe something like lead oxide, or lead oxide and carbon monoxide. The carbon monoxide can pick the oxide from lead to form carbon dioxide, and then you get lead metal. So this one you heat in presence of a reducing agent. So the reducing agent that are commonly used here are carbon, what we refer to as coke, and sometimes you can use a carbon monoxide to also bring about the same. So you can reduce by using carbon or carbon monoxide, but the best is carbon, because carbon monoxide, we know it is poisonous. So it can reduce, and then in the process, you get the metal. So smelting is just a process of reducing by heating the metal with a reducing agent. And then the refining process, so the refining just means to purify, and we have various ways of purifying. One of the methods of purifying is we can use electrolysis. I think you can use electrolysis to purify the material, just to remove impurities. I know for copper, if you are doing extracting copper and copper has impurity, you can do electrolysis of copper using where you put the copper to be at the anode and then pure copper to be at the cathode, and then you just pass in current. So that at the anode we have copper dissolving, and then it gets deposited on the other electrode. And then there are also other methods of doing extraction. So sometimes you can try to do remove the metal from their ore by using aqueous solution. So hydro means water, you involve water. So this solution could be acidic or it could be basic. So what it does is just corrodes the metal from the ore, and then you get it down there. So if you talk about hydrology, so hydrology is the process of removing hydrometallurgy, removing the metal by using an acidic solution. No, aqueous solution, which can be basic, anything that can corrode, can bring about this process. So some of the processes involved, so you can either do leaching. So in leaching, you just use aqueous solution containing a solution that can come into the contact with the valuable metal. So that solution may be acidic or basic in nature, and the type and concentration of what we call liquefying is normally controlled by the degree of selectivity. So there are factors that can be considered, but just know you can just use a solution to remove that. And then sometimes you can also use solution concentration and purification. So you can again So the stages are 3. So after doing that, you get a solution that contains most of the ions, and then after that, you can also purify further. You can try to concentrate, make it more concentrated by repeating the process several times. And then the last part is just to recover, and we'll see how this one is done. So just know hydrometallurgy, we use aqueous solution to obtain metal from the ore. And then we have electrometallurgy. Electrometallurgy, we use electricity. So this one, we use electricity. Hydro, we use solution. So for electron metallurgy, there are terms that are used. So we have electron winning, which is just extraction of the metal from the ore by using electricity. And then you can refine, what we call electron refining. And then sometimes you can also do what we call electroplating. Electroplating is the process of coating or depositing a metal on top of the other. And we do this for various reasons. One of them is to beautify the metal. Another method is to protect. So you can protect by putting a layer of unreactive metal on top to prevent the inner metal from undergoing corrosion. Or sometimes it's done to reduce the cost. I think an example is a bronze. So bronze is an alloy of copper and zinc, and it's mixed just to reduce the cost and for usage. And then we have got what we call electroforming. So this one is usually a method that is used to make parts of the metal through electroplating. Now there's a diagram here which summarizes what we are trying to say during the extraction of the metal. So we start with the ore. So this ore is crushed, and then there is what we go through a process called screening. So this process of screening just filters the material according to the size. So you can see here we crush and then we screen. If it's an if the size is not of the required measurements, it is taken back through the process until you get the one which is of the right size. And then this one is followed now by grinding. Grinding now means you try to break them into very small particles. So you grind, and then you check if you have gotten the right size, and then you can repeat the process. So you can repeat the process. So grinding, and then you repeat the process. So when you're doing a grinding, if you get the ones of the right size, then you can now pass them through the stages which you have talked about. So you can do concentration, you can concentrate, or if you don't want to concentrate, you can just bring them straight into the extraction process where the valuable element is removed from the ore. And then from here, you get the metal which is taken to the market, and the waste materials are either disposed or sometimes they can be recycled. So there are two ways. Either you can try to concentrate, and then you bring it through this process, or after concentration, you can now take it through. So after concentration, whatever is remaining, the waste can now be taken to what we call the tailings or disposal end. So this diagram just shows the process. So we have the first stage is called the comminution stage, which just has to do with getting the material to the right size. So that's basically, that is the process. So when we talk about extractions, that is the process which is followed. And there's normally a feasibility study which is done when you want to start a process, just like in any other commercial process. You have to explore, find out, and then determine the extent and the value of the ore where it is located. So sometimes you conduct this. I think this one is just to tell us, you look at what you want to explore or to extract and compare maybe the value of the same and the extent of the process. And then normally there are people who do this, people who do economics, they do what we call operation research. They can be able to estimate the quality of the material, the size and the grade of the deposits of the ore before the whole process is carried out. And then a feasibility study is done to see how the whole process is possible. So I think maybe this is not a chemistry as such, but you can conduct a feasibility study to look at the financial viability of the whole process. And then after that, you can now do the other process where you develop now and access the ore, and then now the operation of mining can now start. But we know also we have what we call the declimation of the land, where mining had already been suitable for been done as to be done. To reclaim means you try to cover the land so that it can be used for, it can be suitable for future use. I think we have seen these ones. Sometimes when they do mining, the place where the process has been done is normally left in a very inhabitable position, state, and sometimes you might need to carry out some process to do that. Now there is also another process that is normally used when you talk about metallurgy. So sometimes instead of trying to extract the metal from its ore, you can do what we call recycling. Recycling is cheaper because you don't need to go through the whole process. What you need to do is just to melt, to heat the metal, to clean it, heat it to melting point, and then you can reconstitute it. I think this is what is normally preferred. So it's the most preferred method of obtaining these metals. So when you do recycling, I think it is good because the metal can be used again and again, and it has minimum negative environmental effect as compared to obtaining it from the source. So recycling, the advantages of recycling is it is a cheaper process, and it also has less negative impact on the environment as compared to extracting the metal from its ore. And then we have a lot of this which has been done. I think we'll be looking at an example. When you're trying to get some of this metal from there, sometimes you really interfere with the environment, and it also uses a lot of energy, some of the processes. So I think like aluminium, which is when we are doing electrolysis, you have to melt. We know these metals, they don't conduct electricity in solid state. So you have to heat them at very high temperatures, over 2000 degrees, for them to melt, and then you carry out the process. So these are just the processes which you have talked about. You explore, do some analysis of the ore, the resource, look at the economic aspects, look at where the deposit is, and then people sometimes do modeling, and then some exploration is done, which involves also some technology of extraction, and then the whole process is now put into place. So I think I have some exercise here which can just help you answer that part of extraction. I don't know if there's a question up to there. There were some notes on this, I think. Okay, so I think that just talks about the process. Now we have, we can just look at a few metals. Let me just share this. I know we started late. Let me just share this, and then so we can just look at a few metals, how they are extracted. The first one that we can consider is copper. So extraction of copper from the ore. So copper normally occurs as copper sulfide or copper carbonate. So the ore for copper is a copper carbonate or copper sulfide. And it is extracted in different processes depending on the on the ore. So the most common ore for copper is copper sulfide, but this copper sulfide does not occur as pure copper sulfide. It's actually a mixture of copper, iron, and sulfur. And this one is possible because the size of copper and iron are almost the same. So it's possible for you to get a compound which consists of copper, iron, and sulfide together. And it's normally referred to as chalcoprite. Chalco refers to sulfur. Chalcogens, these are elements of group 6, which includes oxygen and sulfur. And then prite there stands for iron. So it's just a mixture of copper, iron, and sulfur. So so the formula is CuFe. And how we do the process is when you look at this ore, it contains very low percentage of copper. This is what we are talking about, that you need to concentrate first before you carry out the process. So concentrate before you carry out the process. And how to concentrate, it means you remove as much iron as possible and remain with copper in the process. So during the process of concentration, this is done by heating strongly the ore with silicon dioxide in air or in presence of oxygen in a furnace. So what happens is that when you heat this with silicon dioxide, this is the process that occurs. So we are trying to concentrate. So when you heat this with the silicon dioxide, what will happen is that in presence of oxygen, is that the ore will be converted to copper sulfide. And then in the process, you'll get iron silicate and then plus sulfur dioxide gas. So sulfur dioxide will disappear as a gas into the atmosphere. And then this is what we're talking about, causing acid rain. So the sulfur dioxide causes acid rain, or sometimes you can extend the process and use the sulfur dioxide to manufacture sulfuric acid by reacting it with the oxygen to form sulfur trioxide. And then the sulfur trioxide is reacted with the sulfuric acid to form oleum, and then from oleum you get the acid. So what we are saying here is that when you do this, you'll find that in this compound, the copper 2 ions in the ore are actually reduced to copper 1 sulfide. So you reduce copper 1 sulfide, and then you get slag and sulfur ion silicate. Now, how do we separate this? So slag is normally very heavy, so it will deposit when the mixture is formed. It will be deposited in the bottom, and iron sulfide will be on top. So the copper, no, not iron, copper sulfide. So the copper sulfide produced can be further converted to copper oxide just by heating in air. So this is roasting. So this is what we're talking about roasting. So you can roast it in air to get copper oxide plus sulfur dioxide. So the end product here, you get copper, and then this copper that you get is normally not very pure. So what we normally do is that because it's not very pure, we can try to concentrate it. So how do we concentrate it? So one way of concentrating it is we react it with dilute acid to form what we call a copper sulfate, and then copper sulfate is now concentrated by using either solvent extraction, organic, you can extract using solvent, or sometimes you can just do electrolysis. I think the best is to do electrolysis. When you do electrolysis of copper, using copper electrodes and the copper sulfate solution, the copper ions will be deposited at the cathode as copper ions. So I think the best is just to do electrolysis. So what we are saying is that when you get the copper sulfide ore from the above method, that it is very impure. So to purify the same, we just use electrolysis. And this diagram here shows how the solution is electrolysis is carried out. When you dissolve in the acid, you get copper sulfate. And then when you do electrolysis, where you have a plus, the anode and the cathode, and then you bring a current, and you have a solution of copper, we know what happens when you carry out this electrolysis. When it is copper electrode, what will happen is that at the anode, where we have oxidation, the pure copper from the ore will deposit into a solution. So at the anode, they'll deposit into the solution. And then what will happen here is that, so they deposit into the solution, and then they move and get deposited on the anode. So they dissolve at the anode. So they dissolve in solution at the anode, they dissolve into solution, and then get deposited as copper ions at the cathode. So the ions dissolve into solution, and then at the cathode, the copper ions gain electrons to form copper solid. So this is what happens. So the process is shown here. So this is the cathode. So cathode, we have the copper ions which dissolve from the impure copper. So impure copper, this is the impure copper. So the copper dissolves, and then we have some waste will be seen here. These are just waste from the ore. So those ones will move to a solution and get deposited in as copper. So this is what happens. So the process involves purification by use of that, electrolysis, and then you get a pure copper. Now, during the process, we normally get some impurities. So some of these impurities are metal ions, which have not reacted, and they can be used for further processing. So some of the metals that can be contained here are things like zinc, and we know that they can also be concentrated and removed. So I think what we need to do here is to know why do we extract copper? So we extract copper because it is useful. So some of the uses of copper is to make electrical wire, because it has high conductivity, and then in other places it is used to make pipes, water pipes, and even sometimes gas pipe, because it does not react with the water, and it's also easy to bend. It can bend easily. And then boilers and also heat exchangers are made of copper because it's a good conductor of heat and it does not react with water. So we just talked about brass as an alloy of copper and zinc. So this alloy produces a metal which is harder than either of the two. And then there's another one which is bronze. But bronze is just made by mixing copper and tin. And we say the purpose of alloying is to make sure that either you get a beautiful metal or you get one which is superior in terms of properties, or we do alloying to protect the metal from reacting with others. And then it's also a coinage metal. That means it's used to make coins because of the color. So copper, silver, they are called coinage metals. So that is the use of copper. And then we have another one called titanium. Maybe we can look at titanium and then we just take a break from here. So we started late, maybe tomorrow we can start early and finish this section. So titanium is also a metal. It's also quite expensive and very resistant. It is non-reactive. So this metal is light, and because it is light, it's also used to make parts of the aeroplane. So it's quite actually expensive. It's unreactive, and it has also been known to not to react so much with the body system. And recently, it has also been used in medical field to do what we call replacement of hips, joints, hips, and also to do connections of the bones during fracture. So say because of the lightness, it's used to make part of the airplanes. And then because of its compatibility with the body system, it has found use in medical fields. And then it's also used to make pipes, although this one is not very common because this one is very expensive. So why is copper titanium very expensive? It's very expensive because the oxide cannot be reduced by carbon. You cannot heat it with carbon. You cannot you cannot react it with carbon to get titanium plus carbon dioxide. So this one is not possible because when you react titanium oxide and carbon, titanium will combine with carbon to form what we call titanium carbide, because when titanium particles spark, they leave open spaces between the particles which can be occupied by carbon. So because of the formation of this carbon, it is not possible to reduce titanium to form titanium oxide to form titanium. You'll get titanium carbide. So because of this, it makes the process expensive. It has to be extracted in a different way. So the other problem with this titanium is sometimes when it's produced, it can be gotten by reacting with titanium. It can produce titanium chloride, and this one is not very stable because it normally undergoes what we call hydrolysis in the atmosphere. So this titanium oxide, another source, is very reactive. So handling this one needs a lot of care. So I think I've just said two reasons here. You can't reduce with carbon because titanium oxide will form titanium carbide. And then you cannot use titanium chloride as a starting material because this titanium chloride reacts violently with water. So to extract titanium, we need to use other processes and also special conditions. So when you are doing, we are doing the titanium, we try to reduce it and get titanium, and then to reduce it, we normally heat it with very reactive metals. So we don't reduce it using a carbon, but we use metals like magnesium, sodium, and so on and so forth. So I think the process of extraction for this, so for titanium oxide, we first of all convert it to titanium chloride under special condition. So this is the process. So the oxide is reacted with chlorine and carbon to give titanium chloride plus carbon dioxide. And we are saying during this process, other chlorides will be formed because the ore contains the same. So very pure titanium chloride can be separated from the other chlorides by doing fractional distillation. Now, when you are reducing titanium 4 chloride, we said we normally use reactive metals. And one of the reactive metals that is used is sodium. So just react sodium with titanium, you get titanium and sodium chloride. And this reaction, advantage about this reaction is that you can be able to separate the two just by dissolving in water. When you dissolve in water, sodium chloride will dissolve in water and titanium will be deposited. So another method of also reducing, once you have formed the chloride, so you form the chloride and then you reduce. One method of reducing is by reacting the titanium chloride with the magnesium. So instead of using sodium, you can use magnesium, but this one is normally carried out at slightly higher temperature because sodium is more reactive than magnesium. Maybe I would beg, can we stop there, then we start tomorrow? What do we feel, class?
Yeah.
Wacha tuachie hapo, and then tomorrow let's start at 7:30, and then we'll be able to finish this part. Thank you. We just stop there. Thank you. We stop there and then continue tomorrow. Thank you. Have a good evening. Sorry about the technology. I think tomorrow we'll I've known where the problem was. Tomorrow we'll start at 7:30 and we'll be able to cover more, and then we see how this week goes. So thank you and have a good evening. Thank you.
Good night.
Thank you.